Well, hello! Look at this. We meet again. Practice test. Second part of chapter 4.
You're funny, Mommy.
On the test, it will say if you will be using quadratic formula or factoring, or if we're just doing quadratic formula. First step is always the hardest. So first I have to get this set this equal to 0. So this one, I would have x squared plus 6x minus 3. Now this would be a problem where I would say you must use a quadratic formula. So now I'm going to use a quadratic formula. Whoa. I'm zooming in. We don't need your chewing. We have opposite b. So opposite 6 plus or minus the square root. Make sure you always have this in parentheses. Minus 4ac all over 2a. That formula will be given to you on the test, where you have to first evaluate this right here. You have to plug that into your calculator. And if you do that, that is equal to negative 6 plus or minus the square root of 48 over 2. You can either do this the factor tree or using perfect squares. I'm going to go the factor tree just so to remind some people. Otherwise, the perfect squares way is my preference to do this. So I'm going to do this factor tree. I would have 2 and 24. Here I would have 4 and 6. Here I have 2 and 2. Here I have 3 and 2. So now I have to look for pairs. So I'm going to circle one, cross one out, circle one, cross one out. So anything that's circled comes out. So I'm actually going to write it up here. So I have my negative 6 plus or minus. I have a 2 times 2 because both 2's are circled. And then I'm left with this 3 here. This is the only one that does not have a branch. So that stays underneath my root. Square root 3 over 2. So that will be equal to negative 6 plus or minus 4 square root 3 over 2. You have to look at that heart, and when you look at the heart, it does not include that square root 3. So my answer then, because they all have a 3, or I mean all have a 2 in common, it would be negative 6 divided by 2 is negative 3 plus or minus 2 square root 3 over 1, or you could just have negative 3 plus or minus 2 square root 3. Those are the same answers. It doesn't matter which one you pick. Next one is already in standard form. So this one I would also be saying that you must use quadratic formula. So opposite b plus or minus the square root b squared minus 4ac all over 2a. We put this into my calculator, and I get negative 10 plus or minus the square root of 148 divided by 8. So first thing I would try to do is figure out what perfect square 148 is divisible by. So I'd probably start with 64. Nope, doesn't work. Then I would do 49. Nope, it doesn't work. Then I would do 36. Nope, doesn't work. Then I would do 25. Nope, doesn't work. Then I would do 16. Nope, it doesn't work. 9. No. 4. So I can write this as the square root of 4 and the square root of 37. So this would be equal to opposite 10 plus or minus. The square root of 4 is 2. The square root of 37, I can't do anything with that, so it's just like this. I look at that heart. Remember, that heart does not include the square root. So right there would be my answer. And my answer would be right there. They're all divisible by 2, so it would be negative 5 plus or minus the square root of 37 over 4. Next. So the next one. This one would say you can either use a quadratic formula or you can solve by factoring. Now when I solve by factoring, I'm going to choose factoring for each case scenario. Again, you can use the quadratic formula, but you must complete the test in the time that's allotted. So first I'm going to have to move over my 25. So one thing that when you're doing this, you should make sure that here's my x squared x number. Otherwise, you're not going to be able to factor this correctly. Since there's a number out in front, I have to factor this using the box because there's a number in front. That 3x squared. And then I have my 42. Now this might be an easier one to solve with the quadratic formula just because this is going to be a big number. So I have 126. Where do I get that 126? You multiply here. And then I have to add to get my middle number. So add to get 25x. Oops, I already wrote in my numbers. Because those two numbers would be 18x and 7x. Because I already figured it out. So now I'm looking, Lily. Now I'm looking, what do these two have in common? These have an x in common. What do these two numbers have in common? These two numbers have a 6 in common. Then I look, what can I pull out of these two? They both have a 3 and an x in common. And then finally, what do these two have in common? They both have a 7 in common.
Yeah, they
So I have two different numbers. 3x plus 7 equals 0. And then I also have x plus 6 equals 0. So my two answers, I have 3x is equal to negative 7. So x is equal to negative 7 thirds. And x, so I would have to subtract 6. So my answers would be written over here. On the tests, make sure you write your answers over here on this nice line that is provided for you. So those are my two answers there. Next one, gonna solve by factoring again. So first step would be to move over the negative 4x. I have to add that 4x over. So it's moved over. Then I look, what do I have in common that I can take out? Well, I can take out a 2. They're all divisible by 2. There's not an x in the final term, so I can't take out an x. So this is what I have now. And still, when I take out that 2, I still have to factor using my box method because of that 2 right there. So I'm going to use my box method. Inside my box method, I have my 2x squared 10. So I multiply those together. They should multiply to get 20x squared. And add to get negative 9x. So again, you can use the quadratic formula, but it does take longer. So you should write up the factors of 20 if you're not sure. But the two numbers would be negative 4x and negative 5x. They multiply to get a positive 20 and add to get a negative 9x. So again, what do these have in common? What do these have in common so that you can factor out? So on the left, I can take out x. Since this number is negative right here, I'm going to have to take out a negative 2. I can take out a 2x here. And again, since this is negative, I have to take out a negative 5. So I have x minus 2 equals 0, and 2x minus 5 equals 0. So I have x equals 2. Add over my 5 first. Divide by 2, so I have 5 halves. So those would be my two answers. Then if this was the test, I would move over here and I'd write down my two answers. 2 and 5 halves. Next. So first I'm looking at this. I'm going to also factor, remember, you can always use that quadratic formula if you want to. Just make sure to pay attention. Now when I'm factoring this, you're going to have to use the box method, but I personally never like to have this be a negative. So I'm going to factor out a negative 1. And when I factor out that negative 1, that's going to change the signs of each of my terms, just like this. So I'm going to factor using the box method. So in my box, I have 2x squared, I have a negative 3, so that's going to multiply to get a negative 6x squared, and add to get a 5x. So those two numbers would be, let's see here, negative 6, or positive 6x, and negative 1x. Because they add to get 5x and they multiply to get negative 6x squared. So what do these two have in common? They have an x. 6 and negative 3 both have a 3. 2x squared and 6x has a 2x. And negative 1 and negative 3 only have a negative 1 in common. So now I also have to solve that. So if I solve that, I have x plus 3 equals 0 and 2x minus 1 equals 0. So x is equal to negative 3. Add over the 1. X is equal to 1 half. So I have negative 3 and 1 half as my two answers. Next page. So what you could move over the 21. You could use the quadratic formula. You could try to factor. Either way, this would be a 0x if you're looking for b. I'm going to just solve for x. So I'm going to divide by 3 here. So then I would x squared is equal to 7. The opposite of taking something squared is the square root. This is where you have to be careful because you have a positive and negative answer. And I can't simplify the square root of 7 anymore. That would be my answer. So on the line is where I would go. I would write positive, negative, square root 7 for my answer. Next one. When I'm looking at this, there's two terms. So I think, okay, what do they have in common? What can I take out? They're both divisible by a 5 and an x. So if I take out a 5 and x for the first term, that's just x. If I take out another 5 and x for the negative 10, that's a negative 2. And I took out that x, so the x is gone. So 5x is equal to 0. X minus 2 is equal to 0. So x is equal to 0. Here I'd have to add 2. X is equal to 2. So again, on my nice little line, whoopsies, didn't mean to do that. I would write 0 and 2 as my two answers. Imaginary. When I'm writing this, I can rewrite this as the square root of negative 1 and the square root of 144. The square root of 144 is 12, and the square root of negative 1 is I, and I'm done. That's all. Next one. So first thing that I notice in this problem is that this is adding. So I'm going to write adding. That says adding if you can't tell. So adding means I'm just combining the like terms. This one and this one. So 1 minus 4 would give me a negative 3. 6i plus 2i would give me 8i. So that would be my answer. That is what I'm going to write on my line. Next problem. Subtracting. A lot like adding, except subtracting. So I'm distribute my negative in. So I'm going to write 2 minus 5i. This becomes a negative 3. Negative 1 times 3 is negative 3. And then this becomes a negative 4i. So now these two are my like terms because those are my real numbers and these two are my imaginary. So 2 minus 3 would give me a negative 1. Negative 5 minus 4 would give me a negative 9i. Done with that. Division! This is always the hardest part for people. Now first, I see that there's a real and an imaginary number on bottom. I have to multiply with a conjugate. If when you pick out what you're multiplying by, and if the two middle terms, if you don't end up your final answer, if there's still an I in the final answer, you did something wrong, probably from the get-go. So where am I getting these numbers? This always stays the same. If this was a negative 4, this would be a negative 4. If this was 2, this would be 2. If this was 20, this would be 20. This is the same number. This sign in the middle changes. Since this says subtraction, this has to say addition. If this is adding, this would be subtracting. This right here has to be the exact same on top and bottom. The exact same. Now I'm just multiplying by a 1. So now on top, I have to multiply on top, and I have to multiply on bottom. So when I'm looking at this, my first right here, you can do box method here. You can do box method, so this becomes a negative 4. Right here, negative 1 times I would give me a negative 1i. Inside, 3 times 4 would give me plus 12i. And my laps. 3 times 1 would give me plus 3i times I is I squared. Let's say you want to do the box method. Same type of thing. I would still highly suggest to write your division bar here. Over to the side, though, I'll do my box method. You can do the box method on both top and bottom if you forget to multiply each term by itself. So here, box method, 4 times 4 is 16. 4 times negative 1 would be negative 4, and then I have an I. 4 times 1 would give me 4, and then I have an I. And negative 1 times 1 would give me negative 1 I squared. So if you did the both of them, the box method, on top, I'm going to write my division bar down here now, actually. On top, I see an I squared. Remember, that's the same thing as negative 1. So this is just the same thing as a negative 3, this term. So I could write a negative 3 there instead. That's the same thing as negative 3. Now this is like terms, so -4 and -3 give me a -7. And then I have these two i's in the middle. 12i minus 1i would give me plus 11i. Now looking at my box. I can simplify my box. Here's my I squared. I squared is the same thing as a -1. So if I switch my sign. Now these two are like terms. 16 plus 1 is 17. And these two are like terms. And these two completely cancel each other out. So this right there is my final answer. Where will I put my final answer? That's what you're thinking. I know that's what you're thinking. Hey, I'm going to zoom out here. Oh, it's kind of hard to see. But, final answer. -7 plus 11i over 17. Answer. Next one. I look at the bottom of that fraction and I see that there's no adding, subtracting of real numbers. I just have an imaginary one. By golly, by golly. I need to get rid of that I in the bottom. Again, if your final answer that you submit to me still has an I in the bottom, I know that you do not understand this concept whatsoever, and you should definitely get the whole problem wrong. So I need to multiply by I over I, because that will give me my real number. So I'm distributing this I to both of these. You're multiplying. This whole thing on top is being multiplied by my I. That becomes 2I minus 5I times I is I squared. This whole thing gets multiplied by this whole thing. So really it's just 1 by 1. So 6 times 1 is 6. I times I is I squared. Remember, wherever you see that I squared, that's the same thing as switching the sign. So I don't have I squared, and now I'm switching those two signs. So now my answer should go in my answer spot. 5 plus 2I over -6. And my last, final question. It's telling you use the quadratic formula. It's also telling you it's going to be an imaginary number. It's stating that right there in the directions. Make sure you're reading directions. So same thing here. My A, B, C. A is equal to 1. B is equal to -2. C is equal to 10. So your quadratic formula. So now I have this right here. I plug this into my calculator. I get that 2 plus or minus the square root of -36. Divided by 2. Do not forget that this is the whole shebang. It's not just a little bit someplace. Right here, this is the way I have to simplify it. 36 is a perfect square. So I have the square root of -1 and the square root of 36. So if I simplify that fraction, I have 2 plus or minus. Square root of 36 is 6. Square root of -1 is I over 2. You gotta look at that heart. You're not gonna get full credit unless if you look at that heart. So now each of them are divisible by 2. So I can have 1 plus or minus 3i. That's your answer. If you really wanted to, you could put the whole thing over 1. Sure, I'll accept it. That's it. There you go. 13 problems. Test is going to be easy. Ace in the face. Whoop, whoop. Have a great, grand, wonderful day.
Day. Make.
Day.
Day. Wait, day.
Great day. Have a great day.
Have a great day.
Make today great.
Make today great. Make. Make.
Today.
Make. Lily says make today great,
Here we
but
go.
she's not actually doing it.